Steve here for SSI. Welcome to the shop. Today I want to build the centering scope. Some of you have asked me for this project. That's going to be today, so let's get to it. This centering scope, of course, I built a long time ago from plans I saw in a project book of some kind. The acrylic is 3/8 of an inch in diameter, and I spotted it so you could see the dot underneath for the workpiece. The bar on top here is also 3/8 of an inch. So it was a pretty simple build. Basically took a 1-inch piece of aluminum and bored it 3/8 of an inch and assembled it after I milled a little bit. The new one I want to build is 1/2 an inch. So this is a 1/2 inch piece of acrylic. You can purchase this from Amazon. That's where I got this one. And these little mirrors you can pick up on Amazon as well. This one is 1 inch in diameter. It's just a small glass mirror that I contact cemented onto this piece. So the trick is for me on this build is I'm going to build two at once. So these are the aluminum blocks that I plan on using. It's just a standard piece of aluminum. I think it's 6061, but it's been used for other little things here and there, pieces and parts and little test pieces. So I'm going to get them as close to 1 inch square as I possibly can on the milling machine. Then I'll do all of the boring on the lathe. And the only other thing I'll need is just a piece of steel. I don't even know what kind of steel this is. I cut it off with a chop saw either a long time ago or here recently, but I think it came out of a treadmill as a treadmill part of some kind of hinge or something. I don't even know. But whenever I start machining it on the lathe, then I'll be able to figure out pretty quick what it is. I think it's a little bit over 1/2 inch in diameter. The pieces of aluminum that I'm going to use are longer than what I have here, but not by much. This is roughly 3 inches in length as far as the block of aluminum itself goes. I tried to keep it the same length as a standard drill bit. That drill bit's a little bit longer, so that's actually pretty good. But these are jobber length drill bits. I did that so whenever you use this piece, if you can get this in there, you can get a drill bit in there. So the first process of this is to get it to a 1 inch square, or as close as possible to a 1 inch squared piece of aluminum. So I will do that on the milling machine. Here we are back at the lathe. I've got the main body of the centering scope in the 4-jaw chuck. I'm going to drill and ream a hole all the way through the center of this thing. Start out with my spotting drill, then I'm going to move to a pilot drill, to a 31/64 drill, then ream it 1/2 inch. Now I have 2 of these to do because I'm making 2 at a time. So let's get started and get this done. Well, there it is. There's the second one, drilled and reamed, ready to go. And one thing I would like to say is that I know not everybody has a lathe where you can do a long bore like this. I used a drill press for the original one that I built years ago. It is nice to be able to drill all the way through a piece without ever changing anything, which is really good. But if you have a drill press and you have a nice vise, you can probably get it done if you have the right length of drill bits. So keep that in mind. If you're wanting to build one of these, you can drill the holes straight through it in a drill press. The trick is not to move anything between drill sessions. So once it's chucked up in the vise, all ready to go, don't move anything after that other than the spindle for the Z-axis. I'm getting ready to turn down this piece of steel stock so I can use it as the arbor mount for the centering scope. The distance from here to here is a 1 inch. If I remember correctly, I made it 1 inch on the inside as well. Then whatever was in the way when I milled this portion of it just got cut off flush. I measured the internal diameter of this hole, came out to 501,000 on both ends. So at least I know the hole is straight in the proper size. And it is a reamed hole, so it does look real nice on the inside. So this piece I'm going to turn down to about 503 thousandths to ensure a press fit. I will give myself about a 10 thousandths per inch taper on the inch that presses on the inside of this, just to make sure that it goes in smoothly and straight. Okay, this is where we're at so far. So here's the old one, the original. This is the new ones. They both have the arbors in place. They've both been reamed, 1/2 inch diameter holes. Now, the acrylic in these is just a little bit loose. The acrylic's just a smidge under 1/2 inch, so it seems like a lot, but it's really not. But I did go ahead and add 4 1/4 28 places for set screws. The holes on the sides, on 2 sides, are of equal distance. Then on the back and the front, I set them 25% in from this line and the edge. Now these two lines represent the opening that's going to be in here. Now the distance from here to the bottom of the angle is 1 inch. So that's what it is on the new one as well. Then I will 45-degree angle cut it back until it just cleans up. So I'll have to set the machine at 45 degrees and cut from there. The slot was originally designed, I believe, to let a little bit more light into it. So it was a little bit easier to see the dot on this end. Now, this one probably won't have that. I may go ahead and cut a slot down this direction and give the same distance that I have here on this side and just cut a little notch in here. Maybe. I don't know. I'll wait and see what it looks like. But the depth of this cutout is just below whatever the acrylic was. Just enough to give it a little bit of clearance so the acrylic would slide by unobstructed. To do that with this one, since the acrylic is larger, I'm going to have to go down to about 760 thousandths just to give it enough to clear. I'm going to try 750 first and see what it looks like. Then I may have to go another 10 thousandths just to give it a little bit of clearance. Because I'm thinking I'll be able to use these two holes here to help adjust a little bit of that slop and maybe be able to adjust it to center. So that's of course going to have to be after it's polished and assembled and have the X scribed onto it, and I'll use the height gauge for it. But first is first, I've got to get this whole opening, this 1 inch by 750 thousandths, maybe more, opening cut on the milling machine. So my first order of business here is to find the edge of this material so I can get an accurate count of where I need to be. Now that we've got the edge finder a little bit off center, wobbling a little bit, now we've got to move the material closer and closer to the edge finder. We'll actually touch it. And keep traveling slowly. As soon as it goes off center, that is the edge of the material. Now this edge finder is a 1/2 inch in diameter, so to get spindle center over the edge of our material, we're going to be 250 thousandths away from spindle center, which is the radius of 1/2 inch. So now that I've got that set, I know where 0 is. Now I can travel over plus my 250 thousandths. I need to cut a slot that's 1 inch wide. This is 1 inch 120 thousandths from the edge of this material to this line. So when I come back and do the cut, I'll be exactly where I need to be, and I'll also be able to calculate how far I need to go to make an exact 1 inch wide cut right here. Okay, I've got the spindle assembly set up at 45 degrees. I'm going to make this cut for the mirror, but first I want to cut this sharp edge down. Since it's a square, I want to go ahead and take this down to a 45, just 50 or 100,000, something of that nature, just to kind of give it that look instead of having a sharp corner right there. So I'm going to do that first, then I'll set the machine back up and take the 45 on this half until it just cleans up back here to this edge. Now with this piece of metal in the way, I may have to slow down the rotation of the spindle for cutting steel instead of aluminum, since that's going to be the harder of the two metals to cut whenever it gets there. Okay, here we go. There's my 45-degree angle we just cut on the milling machine and the pocket. The piece that was left over, remember I had drilled and put set screws in different locations. So this one and this one, the front and the back, are 25% in from the edge. The two on the sides are straight across from each other. There's the acrylic piece that I'm going to use for the sight glass, and it's going to go in here. Now the reason I put these set screws in mainly is to hold this piece into place, and hopefully I have some adjustability here and here, and possibly on the sides if need be. Now the acrylic has to be polished on both ends. But let's talk about the mirror. The mirror is set in with a contact adhesive. Now this is a neoprene based contact adhesive. You don't have to have it, but that's just what I happen to have laying around, so that's what I used. So both of them are set up. Remember, here's the old one, there's the new one. The new one's a little bit longer. The old one doesn't have the adjustment as far as the screws go. It was just slotted, and these two pieces were pressed in, and I even did a little bit of dimpling around it to hold the piece of plastic in place. So I got pretty lucky when I made this one, and it just so happens to line up. So on the acrylic, after I've milled the ends so they're actually flat like they're supposed to be, because I just cut them off with a hacksaw. So I'll put them in the lathe and put the end mill into the tailstock and just mill it flat real quick on both sides. Now one end of this acrylic is going to have to be just a little bit of a dome, and on the other side is going to be flat. Then I'll use the height gauge with its carbide cutter and a V-block to scribe the line and an X across here. So let's get set up and do the polishing. Now for the polishing, after I've got it flat with the end mill, I'll start out with a 400 wet dry sandpaper, move to a 600, then I'll move to a fine crocus cloth. And that should get me pretty close to clear at that point. Not a whole lot of pressure on that, just a little bit. This end mill is just slightly larger than the plastic or the acrylic. one side of this has to have a arch or a curve put into it to magnify the image that you see. So we'll attempt to put on a little bit of a curve this way. Then we'll start the sanding. So we'll start out with 400 grit. I'm going to use WD-40 as a lubricant. I'll move to the 600 grit. And the crocus cloth. Now I did have to go back and use the cutter and actually recut the end of this because the end mill left a little indentation. Just didn't quite come out like I wanted it to. And I've got the 400, 600, then the crocus cloth, and now I'm going to go ahead and put a little bit of wax on here to see if I can get it nice and clear. It's just a standard automotive wax, nothing real special. This is just the first end of it. And on the other side we still have that little piece right there in the center, so I'm going to take the cutting tool and actually cut this flat. I must have not used the right end mill like I did last time.